Hey kids, Smath here. I've got one final thermodynamics problem to try to pull everything all together. Here's what we have. We have cobalt chloride that comes into contact with a little bit of water, and that's going to make the hydrated version of this cobalt chloride. I really wish we were in session. I would be able to show you this, that this is cool. It goes from a pink hydrated version to a white anhydrous version of this when we heat it up. It's kind of cool, kind of fun. What they've given us is the thermodynamic data for delta H for everything, delta S for everything, and delta G for everything. And they want us to calculate the G, S, and H for this whole reaction. Now, I did have to add in, I made a mistake when I put this together, but this is negative 286. So that's why that's handwritten in. So what we're going to do is just do our standards, and this is going to be a whole lot of delta whatever product minus delta whatever reactant. And we're going to do that 3 different ways. And then we're going to just verify or validate that by doing a delta G equals H minus T delta S and see if the two really are equal. So first thing first, let's calculate delta H. These are all in order. So delta H is going to be products. Let's take that negative 2115 kilojoules per mole. Look at those units, kids. Minus negative 312 kilojoules per mole plus 6 moles times a negative 286. Remember, if it doesn't have a number out front, there's actually an implied 1 right here and an implied 1 right there for 1 moles. So we're going to get things in terms of kilojoules. It's going to work itself out. And if we crunch that into our calculator, we're going to get negative 87 kilojoules. Okay. Now let's do the same with delta S. Smaller numbers. 343, remember these are in terms of joules per. So joules per mole Kelvin minus 109 joules per mole plus 6 moles times 70 joules per mole. Okay. Get everybody happy mathematically. And we're going to find out this is a negative 186 joules per Kelvin. Remember, the moles fell out. The moles worked themselves out because we had coefficients and they worked okay. So we have H and we have S. Now let's get G. Same thing. This is all just a matter of products minus reactants. So negative 1725 kilojoules per mole times 1 mole minus the sum of our reactants, which in this case is going to be negative 270 kilojoules per mole plus 6 moles times a negative 237 kilojoules per mole. Brackets, make everybody happy. And we're going to get a negative 33 kilojoules per mole. So the question asks, calculate delta H, delta S, delta G. Everybody's good. Happy, happy. Okay, we got good units. But what we wanted to do is we wanted to validate or verify that equation that said delta G equals the acronym or the phrase for remembering this is called the goldfish equation, because they say that goldfish are heck without tartar sauce. So I sometimes slip and I just say, we're going to use the goldfish equation, because that's really what this is referred to. Okay, so let's get our numbers now and do this. Let's see if it's really true. Delta H was a negative 87 kilojoules minus, now these were all standard states. Notice that when they were given to us, they gave us the degree sign, the degree sign, the degree sign. That tells me that they were given to us at 25 Celsius or 298 Kelvin. So now I can use that and just say minus 298 Kelvin times delta S. Now, delta S was up here in joules. It was negative 186. So now it's going to be negative 0.186 kilojoules. Okay, and technically, I got to clean this up. This wasn't kilojoules per mole. This was kilojoules per mole. This was kilojoules. Okay, because that's what we're going to get down here. If I crunch this in, put this into Texas Instruments, you know what I end up getting? I get delta G is equal to negative 31.6 kilojoules. That's awful darn close to the estimate we got up top of 33 kilojoules. So what we find is these two formulas really do work in agreement, that we can do products minus reactants, or we can also do a goldfish, G equals T minus H minus T delta S. Two ways calculating delta G. That wraps us up with Thermo 2. The next time I'll see you is in acid base. I'm Smath. I hope this video helped.